Differentials are another way in which we can use derivatives to make estimates. So linearization is a way where we could use a derivative, or more specifically, the equation of a tangent, to estimate y values that are close to the point of tangency. Similarly, differentials are using the derivative to estimate changes in y values. But these are small changes that we're estimating, not large ones, because we still need to stay close to our point of tangency in these changes. So yeah, we are going to be using Leibniz notation here because Leibniz notation is written as a ratio of change in y over change in x. It's what the dy and dx actually stand for, are delta y delta x, where dy is the estimated change in y. And we're saying it's estimated because y is the independent variable, and we don't really have any control over it, but the derivative should give us an estimated change in that. And then dx, because it's the independent variable, it is a tiny change in x. And the idea of how tiny is open to some interpretation, and that what's tiny for some people is not tiny for other people. But you're really not going to be asked a problem where you have to make that decision in a high school or AP calculus course. College, real analysis, you get more into how you make the decision of how small is small enough. So if we take, for example, the function y equals 5x squared, and I want to find dy, in other words, I want to estimate the change in y when the change in x is 0.02 and x is 4. So kind of in other words, if I have this function 5x squared, I want to estimate about how much does y change when x goes from 4 to 4.02. Well, the first thing I need is to find dy dx, and we can find it explicitly or implicitly here, but our derivative of y is going to be 10x. Then dy to dx is a ratio. I can actually separate dy and dx. In other words, separate what are called my differentials, where dy is a differential and dx is differential. I do that by just multiplying each side by dx. So I get dy equals 10x times dx. And we're told that x is starting at 4, and we're changing x, dx, by 0.02. So I can plug those in, and I get that dy is equal to 10 times 4 times 0.02, which is 0.8. And so what this 0.8 is that y changes by about 0.8 when x changes from 4 to 4.02.